Apparently, there's another issue with connecting a bunch of data centers directly to the traditional power grid.
I want to start out with some of the events that we've seen as we started monitoring some of the performance of the load against the system, and really we've seen some voltage sensitivities in the state of Virginia. In Loudoun County in July 2024, we saw about a 1,500 megawatt drop as a result of some system conditions. In this case, switching after a fault on the system, and within 50 seconds, 50, three of those voltage excursions occurred, and the load is monitoring that, and when it sees that happen, it comes offline because it wants to protect its cooling load.
So it sounds like something happened with some of these data centers, and the data centers consume a lot of power, and they just went offline. And keep in mind that the data centers are connected to this traditional grid.
So that resulted in kind of, a shakeup of the system because it happened rather quickly.
And it resulted in a shakeup of the system, which just impacts more than the data center. It apparently impacts everything that's connected to in the grid.
We've also seen another one of 1,800 megawatts in Loudoun and Fairfax counties, and we're now reviewing the results of that. My suspicion is it's going to be a similar type situation. In ERCOT, we've seen 25 load center events between 100 and 400 megawatts over the last couple of years. Because crypto does not necessarily have a lot of protections like UPSs, and so when something happens on a system, they just adios, and the technical term, right? And so obviously working with and dealing with that has been something that they've been in Texas for, maybe advancing better control systems and protection systems.
What I read about these Virginia incidents, both last summer and then just a couple months ago, and what I've heard from sources in Virginia is that, and you tell me if this is accurate, that what happened is several data centers went offline at the same time.
Yeah.
And because they are such huge users, it actually affected the frequency
Yes.
on Dominion's grid.
Yeah. The load comes off, frequency goes up, and then starts coming back and works.
So, I mean, I'm not an engineer, but...
Now, what would happen if it was on a distributed model where the data centers were not connected directly to the grid? Would this problem exist? I mean, the data center could go offline, but it wouldn't impact the entire grid. It would just impact them.
When you affect when the frequency gets out of whack, you can trip off the whole system, right?
Yes, that's a good engineering term. It goes out of whack. You're right. You can both if it gets too low. That's why you have under frequency load shedding, and then also when it gets too high, because a lot of we're running magnets here, right? And so that frequency is really.
I'm sure that the Carnot generator has 2 magnets or something, or 2 coils of wire that they run stuff through.
Enough devices to depend on that frequency and delivery of energy. And,
Well, it seems to me this is a problem we haven't had historically. I mean, if my power goes out at my house, it doesn't affect the frequency of the grid.
Because it's small load, right? Small beer compared to large beer, right? So
I'm not even close to Google, believe me.
Right. Yeah, so it's the amount of load. It's kind of like losing a large generator, right? Except the opposite effect. It's negative generation.
So as we build out all these large load users, then this is sort of a new reliability issue, isn't it?
Yeah, because if you have a bunch of data centers just go offline, it can just mess up the grid that it's attached to, and it impacts everyone. It's like all of a sudden, just the power goes out because of some data center issue nearby. Whereas if you put it on a distributed model, where the data centers aren't attached to the grid, this problem would not exist.
Right.
That has to be dealt with.
Yeah.
We know historically, if we lose generators, it can trip off the grid.
Yep.
Now we got another issue, which is if large load users simultaneously go off
Yeah.
together, it affects the frequency and potentially trips off the whole system.
That's right. Yeah.
So that's what you. So okay. So that's what you're aware of that, and that's what you're working.
And
That's
that's
what
what
I
we're
wanted to
working
find
on.
out.
We want to make sure that, and there's ways of managing that and engineering that, right? And
Right.
understanding what the models are and doing the simulations and then minimizing the potential impact and separation, so that you can have this common mode that might take out thousands of megawatts. So you could quickly get to the a more severe single contingency here if you lose a lot of these all at the same time. So obviously we got to manage that. And again, that comes down to engineering, modeling, and continuing to work with the industry, in this case the large load industry and the power industry, to see how we manage that interconnection. And so we got asynchronous load here, right? And it's not even taking a heartbeat from the system, basically, except the cooling system. And how do you manage that against the rest of the system? And
So it sounds like they still want to keep things connected, because if it's running fine right now, just keep things running the way they are. But now they're noticing some issues with these large data center providers. If they go offline, it takes other things. It's kind of like a domino effect.
it can be done. This is good engineering work. Yeah.
Well, I'm glad you all are on it because this is a fairly new issue. No, you wouldn't have thought about a user knocking off the.
We're running
grid.
toward the risk.
Yeah.
We're going to make this is not something we're going to wait on like the winter or,
Well, good.
or IBRs.
So in the previous video, there were issues with decreasing supply because of retiring coal plants, increasing demand for data centers, and now as they put these data centers in, if the data center happens to go offline, it causes an issue with the grid that it's attached to. So they're trying to do some modeling and simulation to find out how to fix that problem. Or you can just detach the data centers, hook it up to a Carno generator, like a whole fleet of Carno generators, and power it without it being connected to the grid. That would be a crazy idea, wouldn't it?